Okay, so you invest $5,000 in an account for 4.5 years, and then how much will be the account if interest is being compounded quarterly at 4.25%? So which formula are you going to use here?
The first one,
That doesn't tell me much.
P, then one
So
plus R over N.
A equals P times 1 plus R over N raised to the NT power. Okay, so on your test, now there is a problem in your test dealing with compounded interest. So you do need to show the substitution to the formula. All right, so you're going to get A equals P, what's the principal or the original amount? 5,000, because A 5,000 times 1 plus R, what's R? Nope.
Much will be accrued.
You have to rise the decimal, so 0.0425 divided by N, what's N?
N is number of compoundings.
Per year. So if it's compounded quarterly, that means every 3 months.
18 total.
So no, it's per year. So N is 4. So N is 4. Raised to the NT power, so that's 4 times T, and T is 4.5 years. Okay? All right, and then now it's just a matter of you being able to use your calculator. So in your calculator, basically you just type in what you see, and we are dealing with money, so you are going to round off to the nearest cent. So 5,000 times, in parentheses, 1 plus 0.0425 divided by 4. Close the parentheses. Now you need to put that in parentheses. So in parentheses, the exponent, you got to raise to the exponent though. So exponent, parentheses, 4 times 4.5, close parentheses, and then press equal. And so in 4.5 years, the $5,000 will have grown to how much?
$6,047.71.
Yeah. So make sure that that's what you got from your calculator. If you didn't, that means you don't know how to use your calculator. Okay, so how much interest was earned though? Now remember, normally you're assuming that you don't take anything out during that time period, which is not usually the case. You take stuff out of your account, but that's assuming you did not. So how much interest is this about?
$47.71.
Oh, you started with 5,000.
$1,047.
Geez, David, come on. You started with 5,000. You ended up with $6,047.71. So that's $1,047.71. So if you're asked to determine the interest is your principal, the original amount. What's the original amount? 5,000. And then that's what you ended up with. So you're going to say $6,047.71 minus 5,000 gives you $1,047.71. Now, they didn't ask you for that, but that's how you would find it if they did. So they may ask you for how much interest was earned. Okay, compounded continuously. So that's where you're going to use that PERT formula. So A equals P times E to the RT. And so what's the principal in this case? 5,000 times E. What's the rate? Now remember that the RT is your exponent. So put that in parentheses. What's your rate? What's the rate? 0.03. Move 2 places to the left. Times the time. What's the time? What's the time? I'm sorry, say it again. What's the time?
No, it's from the first one, so it's 4.5 years.
4.5 years. Is it saying? Come on, guys. It's given to you. It's 4.5 years. All right, so then you just use your calculator, 5,000 times E. So remember, to get that E, you're going to press second ln right here. Make sure you know how to use your calculator. Raised to the 0.03 times 4.5, close the parentheses, and then press equal. And so in that case, I get $5,722.68, rounded off to the nearest cent. Make sure that's what you got using your calculator. All right, and number 2. So we had a problem like this in the last class period, but you're basically asked, which of the following 2 options right here yields the largest return over 6 years? And let's assume you invest $7,000. So will you get more if you invested at 6% compounded semi-annually or 7.5% compounded continuously? That's a question. All right, now here's the work you're going to do in that case. So you're going to do each one individually. So if you're going to find out how much is in the account at each one. So let's do the 6% first. So you're going to say, and remember, this is being compounded semi-annually rather than continuously. So you're going to make sure you use the correct formula. So you're going to say A equals P, what's the principal? 7,000 times 1 plus R, what's R? 0.06. Make sure you remember how to convert a percent to a decimal. 0.06 divided by N, what's N? Semi-annually, 2. Raised to, in parentheses, the NT power, what's N? 2. What's T? What's the time? 6 years. Okay, now use your calculator. What is that approximately equal to? So 7,000 times in parentheses 1 plus 0.06 divided by 2. Close the parentheses, but that's got to be raised. Oops, wrong one. Let me do it over. So 7,000 times in parentheses 1 plus 0.06 divided by 2, close the parentheses, raised to the 2 times 6 or just 12. And if you're doing this correctly, you should get this. 99,000? That can't be right. I did something wrong. Oh, that's 9,000. I'm sorry. Okay, $9,980.33. Not 32, 33, round to the nearest cent. So make sure that's what you got. So that's how much you earned at the end of 6 years. So this account is not worth that amount. How'd you find out the interest? How much interest did you earn? What would you do? What you just found, you subtract what from it? 7,000. Okay. All right, 7.5%. Let's find that one. So the amount there will be P. What's the principal? 7,000. Oops. Times E, right? Raised to the R. What's R? What's the rate? 0.075 this time. Times T. What's T? 6 years. And then use your calculator. So 7,000 times E. Make sure you're using your calculator correctly. Raised, and then put that in parentheses. So when you raise it to the power, it automatically puts a parentheses there. So 0.075 times 6, close the parentheses, press equal, and you get $10,978.19. Okay? So make sure that's what you got on your calculator. I see, yes?
Is that how you're like supposed to write it out on my test?
Yeah, that's what I said beginning of the class. I said, I need to see it like this. Okay? So I need to see this work. Now, the answer, which one yields the larger return?
The second one?
So you're going to say 7.5% compounded continuously. Okay, now I see that some of you are not using your calculator. I'm assuming that you know how to do this. Okay, so then another, one of the things you should have picked up off the table was this. You're going to take that out. Okay, so number one, it says the central processing unit, CPU power in computers has increased significantly over the years. The CPU power in Macintosh computers have grown exponentially from 8 megahertz in 1984 to 3400 in 2013. And the exponential function that models this is shown. So m of t equals 7.91477 times 1.26698 to the t power. So that function models that exponential growth. Where t, make sure you read this correctly, where t is a number of years after what? 1984. So if this is 1985, what's t? 1. If this is 1990, what's t? 6. Okay. At least you understand how to get that t. Okay. So where and it can be used to estimate the CPU in a Macintosh computer in a given year. Find the CPU power of a Macintosh, whatever that is, in 1995 and of a iMac in 2009, and then round to the nearest 1 megahertz. So basically the nearest whole number. Okay, so let's do the one in 1995. So 1995, remember this says m of t, so you got to plug in for t. What's the time in 1995?
Uh,
11, right? It took you all a long time to figure out that it was 11 years.
It's been a long one.
1994 plus 1's 95, right? Or you could have used your calculator and just say 1995 subtract what? 1984. So t here is going to be 11. So m of 11 equals 7.91477 times 1.26698 raised to the 11 power. All right, so use your calculator. So in your calculator, you're going to say 7.91477 times, in parentheses, 1.26698, close the parentheses, and raise to what power? Do I need to put that 11 in parentheses? No, because it's just a whole number. It's just one real number. And so I get, now remember it says to the nearest 1 megahertz. So round off nearest whole number. So that's about 100 what? 107 megahertz. Now don't ask me what a megahertz is. Google it. It's just like in physics when you talk about joules. I used to know what joules was. I don't know what joules is anymore. Yes?
Can you put it back in calculator one more time? I was trying to write while you were
Okay, so it's 7,000, 7 point rather, 91477 times parentheses, 1.26698, close the parentheses, raised to the 11, and then equal.
Thank you.
Okay? All right, number 2. So e-cigarettes sales. The electronic cigarette was launched in 2007, and since then sales have increased from about 20 million in 2008 to about 500 million in 2012, probably teenagers. The exponential function is given by this. S of x is equal to 20.913 times 2.236 raised to the x power, where x is the number of years after 2008, and that models the sales in millions of dollars.
Which one wants to do?
Hold on. Oh, I forgot to do the other one, didn't I?
Oh, yeah, two part.
In number 1, I forgot to do the second part, 2009, excuse me. So let's do the 2009. What's t in this case in 2009 if you go back to number 1?
25.
2009 subtract 1984.
25.
25? So m of 25 will equal 7.91477 times 1.26698 raised to what power? All right, on your calculator, what do y'all get? Put it on your calculator. 29, 35, 50, so the nearest whole number,
36, 29, 36.
whatever the units is in this case, it's megahertz as well.
That's going to be 2.9 gigahertz.
Okay. All right.
Yeah.
All right, number 2. So number 2, the year is 2011. What's x in this case? 4. So s of 4 will be 20.913 times 2.236 raised to the 4th power. So in your calculator, what do you get?
500. What do you want it rounded to?
Whatever the direction says, to the nearest $1 million. So the nearest whole number.
5.23. 523, excuse me.
So I get 523 million. All right, so 523 million. So in just 4 years, you see this amount right here that I'm circling? What does that represent right here? Oh, you should all know this. What does that number represent? Okay, so in terms of money, represent the principal, but that's not money though, but we also say it represents the original amount. So what does that represent? Huh? The 20 million. The 20 million. Which, problem, didn't it say that in 2008. In 2008, what was the sales? 20 million. They just estimated 20 million. Okay, so this was the original sales in that year. All right, so remember what that represents. What that P in those formulas represent the original amount. The initial amount. We mentioned those words before. Original, initial. Okay, that's important. All right, so it went from about 20 million, 21 million to about how much?
523 million.
Yeah,
Wait till you do the
some rich teenagers.
Wait till you do the 2015.
All right, in 2015, what's X in this case?
8.
8. So S of 8 will equal 20.913 times 2.36 raised to the 8th power.
13,067. Or 13 billion.
Okay, so put in your calculator. So you get this. All right, so you get $13,067 million. Okay? Now, what does that mean?
13 billion.
13 billion?
And you know why they have commercials for it all the time.
Okay? All right, and then number 3. So Skype concurrent users. So the number of concurrent users of Skype has increased dramatically since 2004. By 2013, Skype could connect concurrently 70 million users online. The exponential function, P of t, which equals 2.307 times 1.483 to the t power, where t is the number of years after 2004, models this increase in millions of users. Estimate the Skype users that could be online concurrently in 2005, 2009, 2012, and around the nearest million users. We're not going to do all 3. Let's just do the first one, 2009.
So 9. First one's 5.
Okay, before I go on, well, that's fine. Let's go ahead and do 2009. So 2009,
I'll give a distraction later.
okay, so this model was after what year?
2004.
2004, right? So in 2009, how many years is that?
5. T is
5? So t is 5. So I get p of 5. P of 5 will equal 2.307 times 1.483 raised to the 5th power. So to the nearest million users,
17.
2.307 times, in parentheses, 1.483 raised to the 5th power. If you're using make sure you're using your calculator. So it's about 17 million users, concurrent users. So 17 million concurrent users. All right. Now, what does that 2.307 represent? That's going to be important. What is that?
How many million people started out?
So about 2 million. There were 2 million concurrent users. Make you understand what that 2.307 represents. There were 2 million concurrent users in what year?
2004.
2004. All right, so basically, remember, concurrent users basically means that at any one time, so if you went on Skype, there would be about 2 million users that you can connect with at that when you went online. So now they're saying that whatever year that 70 million represents, so at any one point, if you were to go in Skype, there will be about 7 million users that you can connect with. So that's what concurrent means. Okay? All right. So that was the end of this section. So I will put that section online in my math lab.